Alright, so what we're looking at right now is the packet Investigating Bisectors and Triangles Part 2. And specifically I'm looking at the last page of that, well technically the second to last page where it says Problems to Consider. You're told that you can use patty paper to do these exercises. You can also use the graphing calculators and make up some triangles that way. I'm going to show you another way that you can kind of investigate this. The program that I'm using is called GeoGebra. You can download it for free from the internet, and it's lovely to work with, very simple to work with, and very similar to what we've done in class with the graphing calculators. So you'll see on the screen right now I kind of have this blank surface, and along the right side I've got all these tools that I'm going to be using, and those tool menus are similar to the ones that we've seen on the graphing calculator. I'll show you how some of those work in a minute. So far you've been asked to create perpendicular bisectors on one set of worksheets and angle bisectors on another set of worksheets. And you've done those with acute triangles, right triangles, and obtuse triangles. The other types, though, that we need to look at are the equilateral, the isosceles, and the scalene. So that's what we're going to take a little break here today. We're going to look specifically at equilateral and isosceles, because those two alone will really tell us everything, or should tell us everything that we need to know in order to answer the questions that are on that page. So let's get started by building an equilateral triangle. Now you're going to build an equilateral triangle the same way you build one with a compass. Start by making a segment, and then we'll use our circle tool here, and I want to put a circle at A that goes out to B. Keep in mind that that made now the radius of that circle. So any point that I put on this arc will be the same distance from A as this radius is, because those will all be radii. Okay, so let's make another circle the same size but now center it at B. Keep in mind, because we use the same radius, that means every point on this circle is the same distance from B as A is. Which means, since our two triangles or circles are the same size, that point right there completes the equilateral triangle that we're looking for. So we'll go ahead and put a point there, grab my segment again, and complete those two segments then in the triangle. Alright, now I don't need the circles anymore, so I'm going to go ahead and hide those and kind of put them away for just a bit. They're still there, they're just not viewable. Now I want to make an isosceles triangle. So I'm going to start by making the vertex angle. Remember, that's the angle between the two congruent sides. And I put a point there, and I'm going to put some other random point anywhere on the circle, like so. And there again, we've got radii. So this radius is the same as that radius. But I can move this point around, so I know that DE and DF will always be equal, but EF doesn't have to be equal to those other two segments. And that's where we're going to make our our isosceles triangle. So let's go ahead and connect those. That's a pretty little isosceles. And we'll get rid of that circle for the moment because we don't need to view that. And let's kind of move this around a bit so that we can see it a little more like we typically see isosceles triangles. And I can make it bigger, smaller, I can make it more equilateral, I can make it more TP shaped. But ultimately, we get two congruent sides that were the radii of the circles, and then that other side that may be congruent, may not be. Remember the definition of isosceles, at least two congruent sides. And then this one, of course, being the equilateral. Alright, so I want to investigate perpendicular bisectors and angle bisectors. Now over here, if I highlight this one, you can see where it's last been used as a perpendicular. If I select that, though, on my list I have perpendicular bisector. So, choose the tool and then tell it what segment to bisect. 1, 2, 3. Do the same thing over here. 1, 2, 3. And we can see then that all the perpendicular bisectors come to a common point, that circumcenter. I'm going to change the colors of these lines so that we can view them a little better. So I'm going to make them blue. And these 6 lines, notice how it says line here, those 6 lines are the lines that I just added. They're the only lines that I've used so far. So they are the perpendicular bisectors. Okay, And now when I close it out, you can see the original triangle in black and the perpendicular bisectors in blue. So that point of concurrency then here becomes the circumcenter. And I'll go ahead and put a point there in case we need it later. Alright, the other thing we want to investigate are the angle bisectors. So I'm going to throw those on top of the same diagram. Let's put those in place. And remember, to select an angle, you choose 3 points, just like we did on the calculators. Oh, well, look at what that just did. It put that angle bisector right on top of the perpendicular bisector. Huh, did the same thing there too. Last one, let's see. And it did the same thing. So that's telling us something there. The fact that those are kind of laying on top of, that they are concurrent with the perpendicular bisectors. Now let's go ahead and do this triangle and see what happens. Maybe the same thing will happen, maybe it won't. Well, that one didn't. We've got clearly the 3 separate blue ones. Let's try the angle at F. And that one didn't lay on top either. And then we've got the one at D. And notice that one did lay on top of it, and we can see that a little better. I'm going to go in here and select these lines, and I want to color them green, just so they show up a little better. So all these ones that are currently in black, those are the angle bisectors. The other lines that we've just added, we'll make those green. What I want to see then is I'm going to start moving these points around, and I want to see if the blue ones end up on top of the green ones. And where does that occur? Do they just intersect, like here, the blue and the green intersect? Or do they actually, are they concurrent? Do they lay on top of one another? So let's try the isosceles first. I move it around. For the most part, the blue and the green are separate, except that line straight down the middle. The one coming from that vertex angle at D. It's still right on top of its blue, and it doesn't seem to be that I can move it anywhere where those two separate. We can, however, see that when I move this around just right, they all 3 lay together, but look at what the triangle did. Look at those black segments. Kind of looks a little similar. So let's move that back apart. Let's see what happens over here. This was our equilateral triangle, and notice no matter where I move that point, the blue and the green are still concurrent. They're still together. They haven't separated at all. So that should be enough with what we just talked about right there to get you through those last 6 or 7 questions on that last page. Analyzing when perpendicular and angle bisectors can be concurrent. When will that occur? And from what we know here, you can kind of apply that information then to a scalene triangle as well. Good luck, and let me know if you have any questions in class.